Hi, this is Richard C. I'm answering a question submitted by a student who's probably taking Algebra 2. They want to know whether any of these expressions define y as a function of x. In order for y to be a function of x, the graph of the graph of y equals f of x, when we look at that graph, it has to pass the vertical line test. So it means that for every value of x, there's one and only one value of y. And let's just take a look at this first one here. So I'm going to rewrite this as absolute y equals 1 minus x squared. Okay. Now this can only work, this function can only work when 1 minus x squared is positive, right? Because the absolute value of anything is positive. So this has to be greater than or equal to 0, which means that 1 has to be greater than or equal to x squared, which means that x itself has to be between 1 and negative 1. So there's a restriction on the domain, but in terms of the graph here, if we restrict ourselves between, this is a parabola opening down, it's going to look like this. When x is 0, y is 0. When x is 0, y is 1. If we restrict the domain here between negative 1 and 1, which is the only thing that you can do for this equation to hold, and we're just looking at this upper portion here, then it certainly passes the vertical line test. So within that restricted domain, then yes, the function is 1 to 1. But absolute for this absolute value of y, it always must be, in order for this left-hand side to be true, in order for the right-hand side to equal the left-hand side, the restriction on the left-hand side is that absolute of anything is greater than or equal to 0. So you have to put the same restriction here. Given the restriction, yes, it's fine. Okay, let's take a look at the next one. Okay, so 4 plus y squared equals x squared. So we'll write this as y is equal to x squared minus 4 y squared, sorry. And once again, we have to have a restriction here because x squared minus 4 has to be positive. So x squared minus 4 is greater than or equal to 0. Because y squared itself has to be positive. It's similar to this first one. And so that means x has to be bigger, x squared has to be bigger than 4. So that means x itself has to be less than negative 2, or x has to be greater than 2. The problem is, however, that this is not going to be 1 to 1 no matter what. This is not going to pass the vertical line test no matter where we look. In general, square roots don't pass the we could go one more step here, you see, but you're going to get plus or minus here, square root of x squared. And so that's going to cause us to fail the vertical line test. So this was a yes. This was a big yes. This is a big no. So let me illustrate this with a value that's in the domain of this function. We'll pick 3 when x is 3. what happens? You get or plus y squared is equal to 9. Y squared is equal to 5. And so y is equal to plus or minus the square root of 5. So for a given input of 3, you're getting two outputs, two different values for y, and so this will fail. Let's move on to C. So this is a big no. Y cubed equals 5x. That's not a problem. That graph is going to look like this. This is the cube root of x. It's going to be the cube root of 5x. And it's just going to look like a snake. So it passes the vertical line test. Every time you draw a vertical line through that graph, for every x value, there's only one y value. That's why this one failed. That's why this one passes. And then the last one. So part D. Y equals 2 times absolute x minus absolute x here minus 4. So the graph is just going to be the absolute value graph, which we know looks like a V. And we're just going to bring it down 4. And then it'll look like that. And then you can see it passes the vertical line test because no matter where you draw the vertical line, you're going to get, for any particular value of x, you're going to get one and only one value of y. So that passes. The only difficult one was the second one, B, and you just have to kind of think about it. You can, of course, go on a calculator. If you go on, if you're using a traditional calculator, you'd have to put this in. So like a Texas Instruments calculator, typically, if you go into Desmos, you can just put it in this way, and you'll see what happens with the graph. But you don't really need a graph. I think it's pretty clear that for a given value of x, you have two different y's, so it fails. Okay, so that's this question. I hope this was helpful to you, and I'll see you again next time. Bye-bye.